Okay, looking at back titrations, everybody's favourite calculation. They are not as hard as they first appear, and it's really important that every time you come across one that you have a go. An attempt is always better than no attempt, okay? All right, so this is 2014, it was question 30. So we have a batch of dry ice, which is solid carbon dioxide, was contaminated during manufacture. To determine its purity, the following steps were carried out. So as with every other calculation question or multiple choice or exam question, it's really important that you take the time to interpret the information before looking at the questions. So we're told, step 1, a 0.616 gram sample of contaminated dry ice was placed in a clean, dry flask. Now you know me, I like to try and draw or visually interpret what we're being told. Okay, so we've got a 6.16 gram. No, I haven't. We have a 0.616 gram sample of our contaminated dry ice. And it's placed into a clean, dry flask. Okay. We then have 50 mils of 1 molar sodium hydroxide was added to the flask. The sodium hydroxide was in excess. That's important. So I've got added to my flask 50 mils of 1 mole per litre NaOH. All right, awesome. The flask was sealed to prevent the loss of carbon dioxide. Okay, that's important too. Sealed. The reaction was allowed to reach completion, and here's our equation. So we've got 2 NaOH plus CO2 produces sodium carbonate and water. How nice was that? They gave you an equation. And they also told you that this is excess. And we're looking for the amount of carbon dioxide that's in our contaminated lump. So it was allowed to reach completion, which means all of our CO2 has reacted. The reaction has completely gone in this direction, but we know that our NaOH is in excess. The remaining sodium hydroxide was titrated against a 1 molar solution of hydrochloric acid. The average volume of HCl used was 27.6. Okay, so this reaction has allowed to go to completion, which means we've now got our flask, which I'll draw over here, with no contaminated dry ice left over, just 50 mils of liquid. Okay, and that's a little bit of an assumption that you need to make there. The flask was sealed, so we're assuming that the final volume of this solution remains at 50 mils. Okay, and then you're told that it's titrated, oh wow, against, which means it's titrated with HCl. That HCl has a concentration of 1 mole per litre, and the volume that was required was 0.02760. And this is our excess NaOH that's being titrated. Okay, so 2 reactions, exactly the same as the aspirin prac that we did in class. Okay, so remember we added the aspirin, most of us added the aspirin to the NaOH. And then we had excess NaOH, and then we titrated that against HCl. Okay, so it's exactly the same as the back titration that you did in class. And every back titration is going to be similar to the one that we did in class. Okay, so just keep coming back to that. So you can see now you've got 2 reactions going on. We've got an NaOH, and we can get from that an initial concentration of NaOH. We've got information over here where it can tell us the excess number of moles of NaOH that was left over, and then the difference between that will tell us how much NaOH actually reacted with our CO2 in our contaminated dry ice. All right, so now let's look at the questions and see if they're going to step you through or if it's just a straight to it calculation. Calculate the number of moles of NaOH added in step 2. So in step 2, I had 50 mils of 1 mole of sodium hydroxide. So they're stepping you through a little bit. They're getting you to calculate the initial concentration of NaOH that we had. So even though it's only a 1 mark question, you still need to be showing C equals N on V as your formula. Your concentration was 1. We're looking for the number of moles, and our volume was 50 millilitres. So our number of moles initially is 0.05 moles. And I'm going to write that up here. Okay. Calculate the percentage purity by mass of this batch of dry ice. Okay, so now we've got a little bit more info now. We have an initial concentration of NaOH. Now that we've read the question, we now know we're looking for the mass of CO2 that reacted with the NaOH. If we're looking for the percentage purity, then we're going to need to put the mass of the CO2 that reacted over our initial mass of the contaminated stuff times 100 to give us a percent. All right, so I need to get to this mass. So what do I need to know? I need to know something from this reaction up here. Now, you've looked at this reaction a million times. You know that it's a 1-to-1 ratio for HCl to NaOH. Okay, but it's still a really good idea to show that somewhere. So what information have I got from the titration, the back titration? I've got a concentration of HCl, and I've got a volume of HCl, and I've got a volume of NaOH. So that means I can find the number of moles, of little NaOH molecules that are sitting within this flask. So the number of moles of HCl equals C times V, which is 1 times 0.02760. So the number of moles, I'm just going to draw a little box around here, number of moles of HCl that reacted with that NaOH was 0.02760. So this number tells us the number of moles of NaOH that was left over in that 50 mils. Okay, we don't have to find the concentration because we really only need to know the number of moles of NaOH that has reacted to be able to find the mass of CO2. So our excess NaOH was 0.02760. The number of moles that reacted is our number of moles initial minus our number of moles in excess. Minus. Which equals 0.0224 moles. Okay, now it becomes like any other calculation question. We know the number of moles of NaOH that reacted, and I want to know the number of moles of CO2. The number of moles of CO2 is the number of moles of NaOH divided by 2, because it's a 2-to-1 ratio. So it's 0.022412. We can see that's 0.0112. So to get our mass of CO2 for here, mass equals number of moles times molar mass. We're dealing with CO2 still. So it equals 0.0112 times 2 times 12.01 plus 16, always showing that molar mass calculation. That is 0.493 grams. So you can do a little bit of a woohoo at that point because your mass of CO2 has come out as less than your mass of your contaminated CO2 sample. If this number down here is bigger, then you've stuffed up somewhere. You need to go back, check that you've used your ratios correct, that you haven't multiplied by 2 here, for example. If you multiply by 2 here, you come up with a mass of 1.7, which is going to be wrong, okay? And we finally show that as a percentage of our original, so 0.493 divided by 0.616 times 100 gives you 80.0%. And I'm showing this to 3 sig figs. So if we come back to our question, the smallest number of significant figures given in the question is 3. So that's as accurate as we can be in our result. So you actually had to do 80.0 as a percentage. Okay, so hopefully you're starting to see that the more of these calculation questions that you do, the easier it becomes. I still like drawing a diagram along the way if you can, because I think it helps you to visualize what's happening, but up to you. Okay, so you can go back to those harder